In exactly 1 year, some of you will be celebrating your first job, and some of you will still be sending resumes with no replies, no interview, no idea what went wrong. It's not because you are weak, it's because nobody told you the truth. So, welcome back to my YouTube channel. Let's grow together. Now, this video is going to be the roadmap for placements in 2026. But there's an obvious question. What is the requirement of this video? So I figured out a very simple loophole that I've seen in a lot of videos related to placement roadmaps. That is, they mostly focus upon what to cover up in DSA, what to cover up in aptitude, but rarely touch the specific topics that you should learn in core subjects. Be it DBMS, OOPS, computer network, operating system. Many of the roadmaps avoid explaining what to cover up within these subjects. So this video is going to tell you everything that you need to get placed in 2026. So let's get started. Now when we talk about placements, it generally consists of four different things. First is your core subjects, second is data structures and algorithms, third is aptitude, and fourth is your resume itself. So talking about core subject involves database management system, operating system, object-oriented programming, and computer network. They are the foundation of computer engineering, and you require a strong fundamental knowledge of these core subjects to actually be called a good engineer. Now, since this is a roadmap based video, we have to be strict with the timeline. So, let's assume that a particular student who is watching this video is going to study for approximately 6 hours every day. Now I'm going to tell you on the basis of this assumption how much time would be required for studying each and every subject and how can we complete entire set of core subjects within 2 months itself. Database management system is going to be the very first core subject that you have to cover up, and it will take 1 week for you to study it entirely. Now talking about database management system, you have to learn it in two parts. First is relational language and second is database design itself. When we talk about relational language, first of all, it will involve learning the theoretical aspect of database management system, like what was the history of DBMS, purpose of DBMS, architecture of database, and everything associated with it. Later, you are going to learn about relational model. What are the keys? What is algebra? What are schemas, structures in relational model itself? Along with it, you are going to learn about constraints as well. Once you have good foundational language of these things, you are going to learn about structured query language. Where in SQL, you are going to learn about types of languages like DDL, DML, then aggregate functions, set operations, nested subqueries, and everything associated with SQL. Once you know this, you can jump to intermediate topics like joins, views, index, and transactions. And always remember that you have to learn joins not only theoretically, but you should be able to write queries associated with joins. Because most of the times, a good database management system student is able to write queries, complicated queries that are associated with joins. Later, you have to also cover up advanced SQL topics like functions, procedures, triggers, and recursive queries. Once you are done with it, you can also touch a topic known as PLSQL, that is procedural language and structured query language, if you are willing to do that, or else you can start with the part 2. And part 2 is database design itself. Talking about database design, it is going to help you to create database and design database in the best way possible by following the best practices. So it is going to have two different parts. First is ER model and second is going to be relational model. Talking about ER model, you have to first of all understand what is entity relationship diagram, what are different attributes associated in it, what are different parts, what are different design phases in ER diagram. Later, entity relationship diagram to relational model, how to convert it, then extended ER diagram. These are some things that you have to know, and after knowing this, you can learn relational model. Where in relational model, you have to learn about decomposition using functional dependencies, as well as normal forms. What is normalization? What is 1NF, 2NF, 3NF, 4NF, BCNF? everything associated with it. And once you do that, you are good to go with database management system. And just a point to be added, I've not included learning MongoDB or other databases in this because that you can learn while building the projects. But these things you should actually know before building the project, right? Tools can be learned while building the project, but these concepts you should know before building the project so you create an optimal project that is required. Now, talking about the resource that you need to actually learn database management system. So there is a book known as Database System Concepts written by Abraham Silberschatz. You can follow it to cover up all these topics. Now, since we have completed database management system within the first week of our preparation, so next thing that we have to start is object-oriented programming. Object-oriented programming is going to take 2 weeks to complete and it is going to be covered up in three phases. First is foundational phase, second is C++ specific phase, and third is Java specific phase. Talking about foundational phase, it is going to cover up all the theoretical concepts that are involved in object oriented programming, like what is object oriented programming, procedure oriented programming, what are advantages of OOPS, etc. After that, you are going to learn the actual concepts that are involved in OOPS, like abstraction, encapsulation, what is class, what is object, inheritance, polymorphism, interfaces, and everything related to object oriented programming and few principles like solid principle as well. Once you know these things, you are good to go with the language specific part of object oriented programming. Since you know theoretical part, now you have to see how each and every language implements it. So in C++ specific phase, you are going to learn overloading. What is function overloading, what is operator overloading, access specifiers, constructors, destructors, static and non-static data members, friend function, this keyword, nested classes, etc. After that, you are going to cover up inheritance and its types, virtual functions, pure virtual functions, abstract classes, interfaces, everything. Like from polymorphism to inheritance to abstraction, as well as multiple inheritance, how it is supported in C++, everything related to it to be learned in this part. One more thing that you should learn is standard template library, that is STL, because it may not be directly related to object oriented programming, but it provides you a lot of abstract data types and functions and interfaces that you may require while coding up your application. After C++ specific part, the thing that you have to learn is Java specific object oriented programming. In it, first you have to learn about the core things like JDK, architecture of JDK, platform independence in Java, how is it achieved. Later you have to learn about this keyword, inheritance, polymorphism, abstract classes, interfaces, their implementation in Java, why multiple inheritance is not supported in Java. And then real world Java is to be covered up, where real world Java involves garbage collection, packages and libraries, built-in classes, exception handling, file input output, as well as threading and multi-threading. And apart from that, you should know about collection framework as well, because it is also providing you the abstract data types that are required to be created manually if you don't know collection framework. So in this way, you are going to cover up object oriented programming within 2 weeks. Now, since you have covered up object oriented programming, the next thing that you are going to learn is operating system. Operating system is going to consume 2 weeks and it is going to be covered up in 7 different phases. First phase is going to be foundational phase. In it, you are going to learn about what is operating system, type of operating systems, services of operating systems, operations of operating systems, architecture, system calls, linkers, loaders, booting, everything. This creates a basic foundation of operating system. Once you cover it up, you are good to start process management. In process management, there are going to be three things. First is processes, second is thread, and third is CPU scheduling. In processes, you are going to learn about what is process concept, scheduling, inter-process communication, type of IPC, operations, etc. In threads, you are going to learn about multi-core, multi-threading, libraries, and threading issues. Once you cover this up, you are good to start CPU scheduling. In it, you are going to learn about different scheduling criteria, scheduling algorithms, threading, multiprocessing, real-time scheduling, etc. Once you complete this, then you can start process synchronization. Process synchronization is going to have two parts. One is synchronization tools and second is deadlock. In synchronization tools, we are going to learn about critical section problem, Peterson's solution, mutex, semaphore, etc. And in deadlock, we are going to learn about deadlock handling, deadlock prevention, avoidance, and recovery. Since we have completed process in its entirety and start with memory management, it is going to have two different parts. First is main memory and second is virtual memory. In main memory, you are going to cover up contiguous memory allocation, paging, structure of page table, and swapping. And in virtual memory, you are going to learn about demand paging, page replacement algorithms, allocation of frames, and thrashing. Once you cover this up, the next thing that you are going to learn is storage management. So in storage management, you are going to learn mass storage structure, HDD, NVM, RAID, that is redundant array of independent disks, IO hardware, streams, and performance. And the last thing that you're going to learn in terms of the theoretical aspect is file system. So file system is going to be covered up in three different things. First is theory, second is implementation, and third is advanced concepts. So talking about the theory, it is going to cover up access methods, directory structure, protection, etc. In implementation, we are going to learn about file system structure, operations, and allocation methods. And advanced concepts is going to include file system itself, mounting, partitioning, file sharing, virtual file system, as well as remote file system. Once you cover this up, you literally have covered up almost all the important concepts that are required in operating system. But one more thing that you have to do to have an edge over others is to learn about one of the operating systems. That is, you have to do a case study. And I'll suggest you to do it for Linux. Like you should know everything about Linux, be it its working, be it its directory structure, process management, file management, everything, as well as the commands that are used in Linux. How is it different? How is it open source? How is it more secure than Windows? Everything related to it, and it will give you an edge over others. So in this way, you can learn operating system, and all these concepts can be covered up in 2 weeks. Now, the last core subject that you have to cover up is computer networks. For computer networks, you will require 2 weeks itself. And how are we going to cover it up? There is a very simple strategy for it. First of all, you have to learn theoretical basics, and the basics would involve different models, and models would have different layers, and further, you have to just learn those layers. Like, first of all, in foundation, you have to learn about protocols, standards, what is computer network, different topologies, and then different models. Like, there are two different models, one is OSI model and one is TCP IP model. In those two models, there are going to be different layers, like physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. This is the layer technology for OSI model. And in that, you have to specifically learn about each and every layer, how functioning happens in each and every layer, like what are the different transmission media in physical layer, be it guided or unguided media, and everything associated with it. Then you have to learn about data link layer, how MAC is implemented and everything. Then network layer, you have to learn about IPv4, IPv6, how its datagram is there, and subnetting, supernetting, addressing. Everything is to be covered up in network layer. Then you have to learn about transport layer, where you are going to learn about UDP, TCP, how their datagram is different, how is one better than other. And also in each and every layer, there are going to be other protocols as well. Like in network layer, rather than IPv4, IPv6, there is going to be ICMP, IGMP. These protocols are to be covered up as well. Then in application layer as well, there are going to be different protocols. You have to learn about them in depth, and that is more than enough for you to learn in terms of computer network. But one more thing that you have to remember is, in computer network, there is going to be a theoretical aspect, and one is going to be your numerical aspect, where in numerical aspect you have to actually do the calculations. Like, it can be related to creating a subnet, creating a supernet, be it classless addressing, classful addressing, anything in that you may be expected to use CIDR notation or anything as such. So you have to be prepared for both the things, because sometimes they are going to ask you theoretical things, but sometimes they are going to ask you actual numericals that are involved in computer network. And in this way, you are going to cover up your 2 weeks for computer network. The best resource that I can suggest you for computer networks is Data Communication Book by Baron Carosa. That is the resource that covers up everything that you need to learn about computer network. So now with this roadmap, you are going to cover up all the core subjects within just 2 months. Now what's next? You have to focus upon data structures and algorithms. Talking about data structures and algorithms, problem solving demands consistency. So you have to continuously do DSA, and I'll suggest you can follow two resources. If you are in first or second year, you can go with Striver's A2Z sheet that has around 450 plus questions. And if you are in third year itself or in fourth year and you have not started DSA, you can go with his interview sheet, which has around 180 questions and it covers up all the important topics as well. So it's in your hand. Like there is already content available for data structures and algorithms, so I don't have to dive deep into it. I'm going to give the link in description regarding A2Z sheet as well as interview sheet. Apart from that, talking about Aptitude also has a lot of roadmaps created regarding it. So I don't have to cover it up in this specific video. I'm going to share the link of aptitude based tutorials as well in the link itself, in the description itself. Now, the last thing that you have to consider is your resume, because I've told everything about core subjects. There is plenty of content about data structures and algorithms on internet. There are playlists for aptitude, but what about resume? So there are three things that you have to consider in terms of resume. First is your set of achievements that you have. Second is set of projects that you have. And third is set of work experience that you put in your resume. So talking about projects, it has two options. If you have mastered a single tech stack, keep all the projects specific to that particular tech stack and play on your strength. Apart from that, what you can do is, according to the JD, you can change all the projects, but how to build those projects? Simply master a single tech stack. It can be anything. It can be MERN, it can be Mean, it can be a Python based tech stack, it can be Java based tech stack as well. But I would recommend, if you are preparing for placements and you are targeting the companies from the range of 5 to 15 LPA, then a project which is Java, based on Java specific tech stack can actually help you, because that is something recruiter mostly looks for. Okay, that is one suggestion that I would like to give. Learn Spring and Spring Boot and React as well. So you can use combination of both of them to create the projects. That is one thing. Now talking about hackathon section. So you have to participate in a lot of hackathons to make sure your achievement section becomes rich. Because every recruiter would love to know about your co-curricular activities as well as the competitions that you participate in. It can be ICPC based competition. It can be hackathons. You can also publish your research papers. That also adds weightage to your resume. And one more thing is your work experience. So it can involve any kind of work experience that you have in terms of engineering. Like it can be your former internship, former leadership experience. But mostly what they are expecting there is having an internship. So all you can do is you can search for any kind of internship on LinkedIn or any other platform, or through contacts you can do one internship so it can add weightage to your resume as well. So what you have to work upon is, first of all, create 2 to 3 very impactful projects that will add weightage to your resume itself. Next thing that you have to do is participate in hackathons. Even if experience gets added into your resume, it is better than not having any experience regarding competitions, right? You can publish IEEE papers as well, do that as well. And the last thing is, do internship somewhere. It can be free internship, there's no issue in it, but you should learn from it. Should be something quantifiable that you can add in your resume. And if you are able to do that, that gives an edge to you, because the person who is going to hire you knows that okay, he has worked for a particular company and he has given deliverable outcomes as well. So in this way, you have to work upon your resume as well, and you are prepared for placements. The roadmap is in front of you. What happens next is your responsibility.